Shauman?
Yeah.
Yeah, so we're still doing the first hour for the recitation and the second hour for the office hours, right?
Yeah, correct.
All right, just making sure. Thank you.
Okay. I think I'll start regardless the number of people here. Sorry for that. Okay. So I don't know. Like, I don't see anyone asking questions, like posting question about compiling the file. So I'll assume everyone should be able to compile the file and get your exe file to run your VESP machine. Okay, this is what I would assume. And then within the homework, I think it's stated pretty clearly that you want to start your program at some specific location. Okay, so I assume it's going to tell you to start from 0 to 0. So when you write your code, if you have like Excel or something like similar to that, I want you to start writing your code at 0 to 0. And then when you're writing auxiliary move, the address should be corresponding to the line that you want to change it. Okay. Why I want that is because when I'm going to run your code, so if your code doesn't run, okay, whatever reason you gave me, I will take 50 points off, like half of the points off. I'm going to get your code and then put into my local VESP machine on my end, and I'm going to try to run it. If it doesn't run, or if it's stuck in the loop, I think each one of the problems is worth like 20 points. I'll take 10 off, no matter what result you show me. Or you said you can run it and you show me the screenshots, I will take 50% off. It has to be able to run on my end so that I can make sure that you get everything correct. Okay. It's likely that you're going to be able to in the midterm, professor might want you to write auxiliary move as well. I think this is a huge part. It's fairly important. Okay, for those of you who just joined, I just wanted to make sure that I just wanted to tell you again, if I cannot run your code on my end, I'm going to take 50 points off. And then when you start to write your code, make sure it starts at address 0 to 0. So let's say here, when you're running the code, when you're writing a code, it's going to tell you to enter a program, okay? And it's going to say enter a program's starting address. Make sure you put in 0 to 0 here, okay? And then make sure your file is going to run. If it doesn't, I'll take 50 points off. I think I'll make sure I'll send an announcement since a lot of you just is not here. I'll make sure I'll do that. Yeah. And then I was asking for a screenshot. So let's say, just put an example here. This is previous year's homework. It says you're modifying memory, right? And then it says the decimal numbers are from locations hex 40 to hex 4F, right? Correct? And then what I want you to show me is after this for loop was done, what was in those locations. So in the VESP machine, what you can do, so you can display memory. So here I want to display 040 to 04F. And then just give me a screenshot of what that looks like. Okay. And then I would suggest you, so it asks you to write, it's going to be similar. It's going to ask you to write VESP 1.0 program, right? But as we have learned in class, VESP 2.0 is basically 8 more instructions, right? So I would suggest you to use VESP 2.0 machine instead of VESP 1.0 to debug your code or to run your code. since I'm going to run it in VAS 2.0. Why is that? Because 1.0, you cannot load a program, which is like, if you have like a file, you want to load it.
I have a quick question.
Go ahead.
When we're writing the program, should it be in like a .txt file?
It doesn't really matter. It's just the extension of the file. It doesn't really matter. I think it would treat it as a txt and then just read it. You can name it as .vasp. I don't know if you can see it here. It's in Chinese. So you can name it with the extension of .vasp. It's just going to be treated as a txt as well. Like when I manually enter the program, let's say I'm reading it from a file, I have to put an extension there as well.
Okay.
So it doesn't matter. It doesn't really matter.
All right.
And also for the locations, so we shouldn't include the X for the hex. It takes it automatically. We just have to include like the 04004F, and it knows that it's a hex, right?
What do you mean by that? You mean in your code or in like
no,
VAS machine?
In the VAS machine, like it
Yeah,
knows
like let me show you again. So
I think you did it, yeah.
Yeah, so 04F, right?
Mm-hmm.
So you understand it's a hex number, and then it shows from 040 to 04F.
Yeah, right. Yeah, perfect. Thank you.
Cool. Like I can't read the chat at the same time, so if you have a question, please just interrupt me.
So for these are four like 4-digit codes, right? Like we're sending because I saw you type like 3 digits for like 04F, but for VESP 2.0, right? Is it not 4 digits?
It's technically 4 digits, but in the quote VAS machine here, you only get like 3 digits of freedom. So you can, as you can see, 3 hex digits here, and to the first address 3 hex digits. So technically you can only show 3 digits. And then I don't expect our code to be that long, so you would need actually 4 hex digits. Okay. It's just a simulation. It's just the way the professor writes the C++ code.
Can I see a sample like file you wrote? I just want to see the structure of it.
Like just like this.
So here you have four like digits, right?
Yeah.
So one's your address, one's your like for the function, and then the rest 3 are the address, right? Like that's just okay. So we would do the map and like the memory map, and then like write this out by hand and then put it in a file and to pass it to okay.
Yeah, do something like this. Let's say I just stop here, right? And then this is your old code. So this is something you don't want to type in. This is something for your reference. So you know, okay, this is memory 00 is register A, 001 is register B, 02 is you call it index, 03 you call it index +1, 04 you call it index +3000. Okay, and then this is where you start your code, right? You put it there. This is the address. Okay. Okay, let me put one more line. So this is address. So you're starting from hex number 020. Okay, you have four digits, but you can only specify 3 digits. You can't start from 1002. Just like how the way he designed the VAS machine. Okay, and then when you're writing it, put this on the side as of like the Excel file I showed you like in previous recitation. To put it in the side, but when you're writing your code, let's say I just do whatever. Okay, and then you just copy this into your like text editor, any text editor. Just put it there. Okay. Just submit this.
Okay, and okay, so just to like make sure if it's running or not, how would we pass that to like, so we would pass that to the a.out, right? And so like every time it asks for a new prompt, it would like feed one based on the new line separator.
Yeah. So when you have a program, let's say, okay, I can't, I could, but you guys can try it out. So when you have a program, okay, and you just specify the name of the program, you can put it into the same folder, so it will be easier to use. So let's say, so enter a program. You can start it from here. You can read it from a file. What I say is you save it to a file. But when you're writing VASP 1.0, you cannot use any function that's larger than 7, right?
Okay, right.
So because like that's something from VASP 2.0,
Right.
right? So you can still write the things and then put it into a file and then read it from there. So enter the file name, like whatever you name. So it can be VASP or it can be TXT. It's just the way you put it in the extension there. It doesn't really
Right.
matter. Okay, and then
Okay.
you read the file, but there's no file in this directory. But
Okay.
you get what I mean?
Yeah, no, I get exactly what you mean. So we have to run it from within the program. Okay.
Yeah, and then I want to emphasize it again because every time someone submit it, there's gonna be code that's unrunnable, and then I take points off. People's gonna complain. Every time there's someone that's gonna do that. So make sure your code start from 202, and then we are referencing it. Just like let's say we have an auxiliary move, right? The address is gonna be the one here that you're gonna reference. Is that clear?
Sorry.
But is that clear?
Yeah.
Oh, go ahead, Nina.
Yeah, sorry. Is there a program we have to download for a Vespa, like to download Vespa and stuff?
Like the VASP itself was like C++ code on Elms, and then you just have to compile it and put it into like a a.out file or anything.
Like, can you maybe show us an example?
I think I haven't done it before. Just compiling it.
You don't have to download this or anything, because I've never seen that before.
Okay, let me pull it up. I have to log into my Elms.
And you said you're testing on VESP 2.0, right?
Yeah. Because 1.0, you have to manually enter every single line, which I do not want to do.
Okay, so we should also test on VESP 2.0, but pretend like it's VESP 1.0 and only use.
But so for the first problem, you ask you to write a VASP 1.0. So I don't want to see an instruction that's larger than 8. Okay. So it's like 8, 9, A, B, C, D, E, F. That's not allowed since there are instructions for VASP 2.0.
Right. Got it. Okay.
Okay, give me 1 second. I'm loading it. Okay. Any of this should work. You can download this one. That's 2.0x. And then you download it. This is basically a C++ code, as I mentioned multiple times. So I put it anywhere. And then you do a GCC-O. You can Google it. Okay, I'll Google it. So you can Google it, how to compile a C++ file and make it executable. And then when you're running that executable, this is what you got. And then I think in one of the previous sessions, I have covered this. You can take another look if you are still concerned about this.
I think I see that.
Cool.
Thanks.
Cool. Okay. I think that part is done. So make sure. I want to run your code. I'm going to run it in VESP 2.0, and then we are writing VESP 1.0 code. Don't use any instructions that's larger than 7. 7 is hold should be in anywhere, in any machine. So that should be fine. But 8 to F that you cannot use.
So you said 2.x, and because there's like a few different variations of it, right? So
it doesn't matter that much.
Because there's 2.x, and I believe there was also 2.k somewhere.
Yeah, the first one. Let me see.
So that's
2.3. I think any of this should be fine. Like those are just some modification, but those should be fine.
Okay, so I'll run it on 2.x. I just want to make sure like that's okay, just in case it doesn't work.
Cool. Wait. Yeah, 2.x. I think that's fine. Yeah. Cool. done with this part. So I'm going to talk about the logic of the writing a loop and then what to submit. I think I talked about a little one. Now I will talk about the logic of the loop. Okay. So what we got here is you're just trying to write a for loop. I think everyone should know how to write a for loop. But like it's a for loop in Bash, right? So I'll sort of briefly go through it. So what you do first, so you have an index here, right? And then A is where you're gonna do your, let's say you want to change it to other numbers, you want to do summation, or you want to inverse it. So that's where you're manipulating with A, and then maybe when you do summation, you might want to use B as well. Okay. So what you first do, you initialize X. I'm sorry, initialize index. I use that for like hex number 2. It can be anything, okay? So you have until address. Okay. You have address until memory address until 001F to use them as a registers. So you can define your index here. Okay, it's just something that you want to do, which it's not my concern. I don't really care. Just the way you define it.
Sorry, what does IX stand for?
Index. So like the I here.
Right. Thanks.
Okay, first thing you do, you initialize the index. Okay, since you want the index to start with hex number 40. Okay, second, what you do, so it's like you want to compare if it's larger or greater than 4F, hex number 4F. So second thing you want to do is you compare, or you can say you calculate the complement of 4F. So since you can not do subtraction in 1.0, okay, I'm basically talking about 1.0. If you know how to write it in 1.0, you will know how to run it in 2.0. Since 2.0, you have more instructions. So you calculate the complement of 4F. I think I talked about calculating the complement of a number in one of my previous recitations as well. After your calculation, you get a 4F, right? So if this number IX, so it's like if IX plus negative of 4F, so this is a complement, right? You can put that, let's say this is something you can do. I'm just suggesting you can put this number into B, put IX into A, and then you do addition. If this number is greater than 0, then you exit the loop, right? So like maybe jump, you can think about it. That's something that you're supposed to do. Okay, I'm just telling you the logic of writing this loop. So if not, it's so like the jump, so if positive, the jump will being executed. Otherwise, you'll go to the next line, right? So next line, what you do is you do I index equal to index plus 1. So you're iterating through the loop, right? And then you also want to update it, what is here. Okay. And then you want to calculate index plus 3000. I talked about this once. Why would we need this? It's because like when you're storing your calculation result back to where this address is, like the memory address of IX, you would need this. Since this whole thing would have an instruction, which is 3, okay, and also where you want to store it. So that's why you would need it. If you still do not understand, I would say go ahead, write your code. And then when it's the time you want to store whatever you calculated in A back to the memory, you will have a hard time. And then you think about this again. That might help you when you're solving this problem. Okay.
Can you briefly explain it again, please? The
So
reason
so
for-
when you let's say I have this I have okay I'll let me put it here. Let's say I have mem
Mhm.
I plus mem I plus 1.
Right.
So when you're doing this calculation, right? Whatever
Uh-huh.
you do, you put that number into A, right?
Uh-huh.
Let's say this was in A, this was
Right,
in
right,
B, and
right.
then you calculated this eventually being A. But when you are storing this
Mhm.
back to mem I,
Oh, okay.
how are you gonna do it within VAST 1.0? Since like since it's gonna be 3 let's say what should I do? Like let's do this 300I, or let's do I, okay, which is this one right here, this address, and then 00008 0000, right, which this is the address of A,
Right.
right?
Mhm.
Hence you want one of the line to be like this.
Why do you want a line to be like 3.III? That's the part where I am missing.
So okay, forget about this. When you are doing this, you are storing the value in A to a memory address of I. Okay,
Right.
what I should do? IX.
And you have the address at IX stored in 002 in this case, right?
Yeah, but like yeah, yeah, sure. But how would you do that? You would still need that address of IX to put in conjunction with this 3, which is the instruction.
Okay.
But how are you gonna obtain that line? That line is constantly changing, because where you're gonna store it is constantly changing.
And it's similar to the auxiliary move.
Yeah, that's why it's called auxiliary move.
Okay.
Do you get it? I think some of you get it, some of you still don't. That's what I feel. So
3,
like,
sorry.
go ahead, Nina, go ahead.
Isn't 3 like the opcode or something for move or whatever?
Yeah. So when would you need it? This IX plus 3000. I was explaining this.
Oh, so this is the auxiliary move. Okay.
Yeah. So
right. So this is where okay. I get
when
it.
you are performing this, A into you just want to store A into the memory location of IX. Okay. You would need something like this, right? Which I represents the IX.
Mhm.
I don't know where.
I forgot about auxiliary move.
So yeah, so to I guess remind us again, what the address at XXX is going to be the address at IX, right?
Yeah.
Next door. Okay. Got
Well,
it.
no, it's not where the IX is. No, it's not where the IX is. It's the IX itself.
Right. So you're going to put.
So let's say, okay, for the first one, let me just put another example. For the first one, when we are calculating in the first round of the loop, okay, you're doing, right?
Yeah, I get that.
Right? This is the first thing you do. Like after your calculation of this, you want to store the value in A, since like after this is done, it's gonna be you want to store the value of A into the memory location of 040. Then I put another 0 to be even more clear, right?
Okay.
But this number, this what you want to do, IX keeps changing, right? In the second one, it's gonna be 041, right?
Right.
So we're gonna need an auxiliary move to perform this.
Right. Okay, no, yeah, I understand that. Like.
So now, so since IX is always gonna be first part, or where the parts where this is going to, so you want to do IX plus 3000.
You have lost me again at that last step. So I get that you need an auxiliary move to change the location after 30.
Okay, put it another way. How did you get this line? So you know the location is gonna be this.
Right.
How are you gonna get this line, first line?
So you're going to have to move the address of like 0040 into the location that III is referencing, right? What III is referencing, so you know which address to move to.
Yeah, you already know. No. Okay. Yeah, you already know this number. Okay, let's
Right.
assume this number was in 002.
Okay.
Okay, or you have this number in B, whatever. It doesn't matter.
Right.
And then you know the instruction is 3, right?
Right. So then you.
And then you know the line you want is 040, right?
Right.
So what you do is you just add the two numbers together.
Oh, okay. I see what you're saying. I see what you're saying.
Make sure you get it before I sort of let it go, because this is like, I think this is the hardest part. Is the most confusing part. And then when it comes to the exam, your midterm, you might be going to need to write something like this.
When is the midterm, by the way?
You mean what or when?
When?
After the spring break. I think the professor said that.
All right, thanks.
So are you saying that that IX plus 3000, so you're saying that IX plus 3000 value is like the full line of code, right?
Yes.
So then like, how are you supposed to access that, right? Because every time we've needed to access something, we're always doing like a move or like a load, right?
Yeah,
So,
you move that, right? You just move that whole thing.
oh, okay, you do a move into that line of the address?
Yeah, that's why
okay.
that's why it's called auxiliary move, right?
Yep, okay, I got you.
So
Thank you.
this is a little bit different than the previous one that we saw. That like previous one we do this, and this is like 9999. Okay, right? And then we do auxiliary move to a line in here. That's why, because the load instruction is already known, so it doesn't matter. So you don't have to do this, something like this, right? But here it's different. Here it's like this line is missing, right? So it's like the auxiliary move that we want to change it was this line, and then we know what the instruction is. Okay, so that's why we do this. We do IX plus 3000.
I think the way I remember it, and you can correct me if I'm wrong, so the thing you're trying to do is memory IX equals A. So 3 is like the move instruction, and then A is stored in 000. So that's why you do IX plus 3000. Which I'm not sure what the plus is for exactly, but
plus is you can think of it like conjunction. You just put the instruction with the registers, the location that you want to do things with. You can think of it that way. It's not like it's addition, but like it's not like the addition that we usually calculate the numbers. It's like the addition you use it to get the line of code that you want. I don't know if that sort of makes sense to you.
It kind of does. I thought auxiliary moves when you stored stuff in like a temporary place before you can move it.
It is temporary place. Like this should be like this, right? Well, technically, it should be like 9999. Right? Technically, it should be something that's meaningless. And then you're moving this. What you're moving in was like this. You're moving this into that. And then this becomes your instruction, and then the location where you store it.
Oh, okay. So it's like, didn't we? I think we covered this in like week 4 or something.
Yeah, we covered this before. I was going in pretty quickly. It's not as detailed as we are talking about today.
Oh, I forgot. So it's like first you kind of store it. So 9999 is less than or. Okay. Sorry. I'll let someone else ask a question.
Okay, I'll give you another 2 minutes to sort of understand this, because I think this is the hardest part about this whole homework. If you are resolved with this, like everything else is a piece of cake.
I'm not sure if my next question will get you ahead of where you're going, but stop me if it does. So after you get that address, right, like once you understand like why you do IX plus 3000, how do you execute that address, right? Like how do you execute that command? Because that's basically a full command, right?
What do you mean? Like so like this is so after that, like you let's say you change, this is where just do an addition, right? And then later on you're gonna access the value here.
So
you change one of these lines.
Oh, okay.
So
No, I see,
another
I see.
load, so like
I
auxiliary
see,
move,
I see.
right?
That makes sense. Yeah, you have a reserved spot for IX plus 300. Okay, that makes
Yes,
sense.
exactly. Okay, someone else is asking a question. Okay, I think he's there. He's trying to answer it. Cool. And then okay, you have this, and then what you want to do is you load these two numbers. I'll be brief because this is something you should be able to know to do. So load these two numbers. Okay. And you do addition. So you add them. So it's like we were back to this step. Okay, I'll just put that here. And then you do this, which is the auxiliary move, which you will need. Okay. Questions?
Okay, so the IX plus 3000 or like the IX plus 3000 is not something that we have on the device memory. We have to include that in the code, right?
Sorry, you're a little blurry. I can't really hear you that clearly.
All right, can you hear me now?
Yeah.
All right, so I'm saying the IX plus 3000 is not in our memory. We have to add that. Is that correct?
Yeah, it's not in the memory. Like it's here. Let's say I define it in 0004. You can define it anywhere, but I define it here, so you're accessing it from memory location 0004. And then what I would do is like within here, it's an auxiliary move. I'll load that into this line. Let's say what this address is. Let's say this 040. No, it can't be. Let's say 50. I'll load it to this line. Okay.
Yeah, perfect. Thank you.
And then like okay, and then something about this homework as well. Let's say you have a data array stored in this right. So what the professor does, he used like the instruction 2 to manually load the data to a specific address. What I would do is I would literally just put the numbers here. Let's say from the beginning it's gonna be 0, so it's like this. So I'll just manually put the numbers here. And the line as well. Okay. So you don't have to write the instruction 2 to load it for each one of the numbers for the data array. And then just in case, let's say you're writing the code, right? You're approaching to this. Let's say D, and then you write something here. You write 0000. And then you're getting very close to this line where you put the data array there, right? What do you do? So what you do, you can jump to the line where the data doesn't exist, where there is no data array. So you can just do that. Let's say the data array here is till 004F, right? So what I would do is I would jump it to 0050, which is where there is no data array. I don't want to be manipulating the data array, and I don't want to run those data as code, since they're not the code. If I somehow happen to run this one, right? This is not going to be number 0. It's going to be an instruction for addition, which I don't want. Right? So I will jump. So for whatever, I should put ... here. So data array is going to be for F. Let me finish this. Real quick. And then your code is going to continue on here for whatever you do. Let's say it's just a halt here. Go ahead. Go ahead. I thought you have a question.
Oh, yeah, I think I understand it now. So like basically because you start at 022 or something, you will eventually run into where the data is stored. So you have to jump to avoid it. Okay, yeah, I understand that. Thanks.
Yeah, like just in case like some of you might in case like happen to meet this problem, you're gonna need it. So you're gonna need to jump out of this data array where this would do. It's like when you are coming to this line, what you would do is gonna jump over here, where your code is gonna keep running, keep going, and then like this will be ignored within the part here unless you are trying to access, let's say, the numbers in there.
Yeah, no, I got that. Thank you.
So basically, we are storing them between 40 and 4F, but when we initialize them, do we initialize them like in the code above, like from 0020, and then right?
Like what I'm saying, yeah. Like if you want to initialize the data like the way the professor was doing, you're gonna have to do you just do it from the beginning, right? Otherwise, the number is not going to change. What I'm suggesting is you just put the numbers there, so you don't have to just write the two using the to instruction to load the number manually one by one.
So it's not going to create a problem that we're not having the load instruction, right?
Yeah, as long as the result is correct. So this is what I would do. I would not manually load it like what the professor do in class. I'll literally just put the number there in the corresponding location. Do you see what I'm saying?
Yeah.
Cool.
Notice that sometimes when the professor writes instructions, he writes out like the number, he writes out like load instead of the opcode. Is that what we should do, or should we write the number, I guess?
Just write the number.
Okay. Thanks.
Okay, and then can anyone tell me, okay, after I'm done with this, I loaded, so which is mean the completion of one loop. Okay. What should we do? After the completion of the loop, what should we do?
We should go back to the beginning, jump to the beginning.
Correct. Sorry, I should not go to the initialize. So then you should do this again.
But we should increment I first, or the IX.
No,
right?
like this is incremented here. It depends. Yeah. It depends on how you write it. It doesn't matter. It depends on how you write your loop. Yeah. This is just one way. You're correct. You can definitely do that. So you go back. What was your name? I forgot. Jason?
Oh yeah.
Yeah, I think as Jason suggested, like you don't have to do that. You can do increment at the very end. You can do like it's just different ways of creating a loop. I'm just giving you one suggestion. Okay.
Mm-hmm. Yeah, makes sense. Yeah, it's the same thing as like programming. C program is different language.
Yeah. It's the same thing. The logic is like this, and then this is the hardest part. If you get this, then it's like you're just playing around with it. And then for the second part, you don't have to do this since like there are stuff that will make your life easier in VAST 2.0. I think Professor has talked about it. Maybe it's what was it? Maybe it's instruction opcode F. So it will help you do a lot of stuff. You load whatever was in A to a specific for index, and then you will increment the index as well. So for 2.0 is relatively easier. Usually when I'm grading it, if I can run both of the code and then 1.0 is correct, I usually assume you can run 2.0 because that was a lot easier. Okay, I think that's it. So make sure your code runs. That's the only thing I can say. I want to emphasize it again. Let me ask you one more question, okay? So let's say when I'm trying to modify it, this is what I want. So what should be changed within this loop, what should we change? I want someone that hasn't asked question before to answer me that question. If you get it, like whatever in this, what should be changed if I want this instead of that? Basically use this to cover that. This is what I want to do within the loop. Anything else remain the same. What should we change? No, not you, Jason. Not you, Jillian. Someone who hasn't asked or answered a question before. Because like whenever, if you could answer it, it means you understand it. If no one volunteers, I have to pick. Joseph?
Am I the only Joseph? So I think you would need to augment the line where a equals mem_i plus 1.
Where? A equal to mi plus 1.
Yeah, right. Yeah.
Right here?
No,
Here?
I think that line. Yeah, I don't know. I don't really get it. So
Okay. I think I'm not doing a good job. So okay. What do you get here, right? From this line is what you want, right? Here. But this is where you want to store things. That's basically what I've changed, right? Correct?
You
Oh,
can just
okay,
do
I
ix plus 3002.
Yes. So the only thing we changed is where we want it to be stored at. Is like this line here, right? So instead of, so it was memory of I, right? I changed it to memory of I plus 2. So what you do, you want to do this. And then essentially what you are really changing is to do this, right? You want to change where you want to store the value is. That's it. That's the only thing you change. Everything else should remain the same in your code. Okay, to be more precise, like this has to be changed, like the number has to be smaller, since like you are accessing something weird if it's reaching out to the very end. This should be, let's say, should be E, right? Instead of 4F. Like the whole problem is going to be changing, since like otherwise it's going to give you error. I'm just giving you a taste of what this looks like. All right, you have to think about when you're accessing the memory here. Some of it are code. If you happen to access the code as like numbers and then you change it, like the whole code is going to change and then it's going to be stuck in the loop forever, or it's going to just give you an error. So watch out for that when you're doing things like this. When you're accessing the memory and then you happen to make to access the code and then it changes it, that's really bad. This is like where you want to store things. I want to emphasize it again. It's auxiliary move, and then you want to change it to where you want to store things. So where you want to store to was like the III here. All right, and then you know the instruction already or the opcode already, so you want to add that number together to give you what you want. Okay.
So that's all like auxiliary move is. Then you basically just take the opcode of the instruction, which is a 3, and then all you have to do is kind of add it to the So you have a 0, 0, 0 because you're trying to store stuff in A, but in this case, so you're trying to store stuff in IX plus 2. So is IX plus 2 now like A, I suppose? Is that how it works?
What do you mean? A is A register. IX plus 2 is where you want to store it. I think you're correct. Yeah.
Oh, so IX plus 3000. Okay, that makes more sense. I thought I remembered learning it differently last time.
No. Like auxiliary move just means like you move your values first and then you do the real move, which means like the first move is not the real move that you want. And then as if vice versa, let's say you want to do the other way around. So you're gonna be changing things. This is gonna be 300, and then it's gonna be 9999 here.
Why 9999?
Like this is just something that you're gonna change. If this is what I really want to perform here for this line. You're gonna be changing this line, right?
Yeah.
What this should be? This should be technically what the ix plus 2 value is, right?
Yeah. So 3002.
No, like no. Okay. You have to make sure what this is doing you put the value in A to memory address of here.
Yeah.
For what this is doing is the other way around. You want to load this value to A to register A. So what the second line should be?
I guess you want to use like the move instruction. So actually, no, you want to use the load instruction, which I think it's a 1.
So
If I'm correct.
No. The 3 here is already the load.
Right, and it loads. So it basically loads it into the address.
Yeah.
Oh, so you want to take the contents of ix plus 2.
Yeah.
I guess.
So this 9999 should be ix plus 2.
Oh, I get it.
Now both are auxiliary move. Both are auxiliary move.
So what's ix plus? Could you change the 9999 to like ix plus 2?
Yeah, like you want to change it, so you will want another move ahead of it to change it before you use it, right?
Yeah. Yes.
All right, then that's it.
No, but I was saying like, don't you want to change the 9999 because you just use those as a placeholder, right? When you actually need like the value. So ix plus 2, what would that be? I guess it would just be 0004.
It would just be some number that you want to load the values into.
Oh, so you're loading the values from ix plus 2 into A essentially.
Yeah.
That makes a bit more sense.
Cool.
And you did it all in one step in your case.
You would need another move.
No,
you would definitely need another move. Like this is a placeholder. You would definitely need another move. Let's say I put the value of ix plus 2 in A, or let's say, okay. So this would be load the values of 5 into, I suppose this address is 0 to 5, let's say. So this should be 0 to 5.
Oh, so you're loading 5 into 0 to 5.
And then this completes the auxiliary move. This is address. This is nothing about code. This is address. Let's say this placeholder is an address 0025.
Oh.
And then this is what you do.
So you're moving the address 0025. So 9999 is actually supposed to be 0025. And then you're moving that into 3.
No. 999 is at address 0025.
Okay. So
That's not what it's supposed to be. It's supposed to be the value of ix plus 2.
Yeah.
Where this stores the value of ix plus 2.
Right.
And then I put that value in there. Whatever this should be, I put it in there. And then I load it up.
Oh, whatever the value in 0025, you put it in A, and then you load it into location 025, which is I don't know. Okay.
Okay, Nina, what I would suggest is go back to the lecture and see what the auxiliary move is. This is exactly what the professor talks about, this part. Okay, like don't worry about +2. It's just something the professor has talked about, okay?
Yeah, I should do that. Thanks.
And then this part is the part about this.
It's lecture 3, right?
I don't know which lecture exactly, to be honest. It's just
Okay,
one of
that's
these
fine.
lectures.
Thanks.
And this is what I talks about, and it's very important in this homework. It's both auxiliary move. It's just the things that we're performing is different.
Okay, yeah. Thanks.
Yeah, that's it for me. Unless you have more questions.
I have some like house cleaning questions. So like if we implement it, how would we know if it's executing correctly or not? And is there
Check.
like any way to debug it kind of?
Check your results, like whatever where the things are stored. So I also want, I think I talked about it. I also want the output of the memory address where your data arrays are.
I'm sorry, what?
Okay. I
Oh, you
also
want us to print all the like load all
Yeah.
the memory addresses so you can see what they are. you
so
can verify,
so
right?
so let's say
No, he
here
just wants the
it's-
memory where the array
yeah.
B is, or A, whatever we're loading into.
Correct. So for this problem, the number are stored in hex 40 to 4F. So what I want is you print that number. The first address is 40, last number 4F. You print that and show me this screenshot.
Okay, but it's not like something you want through code. It's just a screenshot you want separately.
It's
Okay.
just a screenshot. Yeah. So I want 2 files for VASP code, and then 2 screenshots. That or multiple screenshots that shows me what this looks like. Like the numbers should be the same for the both code.
So when we do that, do you want us to submit and resubmit the do you want us to like just submit and resubmit the multiple files? Because I don't think Elms
You can
lets
do
it.
multiple at once.
You
Yeah.
can multiple at once.
Yeah,
or-
you can just do add file. And you can
Or
add
you
as
can
many as
you can
want.
zip it, or you can zip it.
Okay.
Whatever you want to do.
And I know earlier you said to like just go into the memory and put the values we want to put into 0,
Mhm.
4.
Mhm.
So how do you do that invest to like just go edit memory as you please?
Yeah,
Instead of,
like so
loading it
this
through-
address is the same address where you code and then you put your data,
Right.
right? Like what I did is like basically change it to the numbers that is what it was supposed to be.
Right. So how do you do that in VESP? Like I don't see a command that.
No,
lets
no,
you just-
No, those are the same code. You're writing your code, right?
Uh-huh.
So you are doing this. Okay, let me show you one
Oh,
example.
so when we go through 040, they should. oh,
Yeah. So
So
when
what-
it's the same when you're writing the code.
In this case, you'd have to jump to where we want to add them, right? Because we want them in 0703079.
Uh-huh.
But I already did like the whole load thing that like the professor did. Is that fine to just keep it like
That's
that?
fine. That's fine. It's
Okay.
either way. It's either way.
So first we jump to the beginning of the where we store address of the where we store the values, then we just input it and then we jump back to the beginning.
Like I said, it's within your code. Like, I don't know if that's clear enough. So when you, this
So-
is like where you write your code, right? And this is where the
Right.
data are stored. I literally like writing the code. I write the data in instead of
Right.
using the load.
So what concerns me about that, right, is that well, I don't know, maybe I'm wrong about this, but does it not execute sequentially, or is all of it stored at the same
So
time?
before you touch this, like before you touch this code, you use a jump. That's something I talked about. You use a jump right here. Before you touch it, like this should be okay. It should be in place.
No,
like this.
that's fine. That's not. I know why you did that jump. That's not what I was asking about. What I was asking, right, that, for example, you call earlier than 040, right? You
Mhm.
call to 040 before you execute what's at 040, right? And we don't actually execute it because we jump over it, but theoretically, right? So at compile time, would it have what, like, do you see what I'm saying? Like,
Yeah. You will access it. It's fine. Don't worry about it. You will access it. So
there's
let's
no problem
let's
with
say
that.
within the first line of code, you want to access the data in the line
Right.
40. You'll get it.
Okay, so there's no compile time problem
Yeah.
with that. Okay,
Yeah.
that was my question. Thank you.
Cause you know what? It's like you're taking your hard drive out, and then you use your fingers to change whatever was in that location already. It's literally what we're doing here, like the way I
Okay.
did it. What the
Okay.
way professor did it was like you
You
give
would
it a
actually
code
code it
to you give it a code to change it. What I went doing was like I just used my hand to physically change it in the memory.
Right. I'm just making sure it works because we're
Yeah.
accessing that memory before we execute like whatever is
Yeah,
stored.
yeah,
at the-
yeah.
So okay.
So
as long as
it's
that
like
works, that's fine.
so it's like debugging, right? To be
Yeah.
honest, like if you go ahead and just run your code and see your result,
Yeah.
you will know if it access there or not, right?
Okay. Yeah. Okay. Thank you.
And I have a quick question. For my
Go ahead.
code, I used two different variables to index, one for A and one for B. So I wouldn't have to like add 3000 or whatever every time. Is that fine?
It's fine
Okay.
as long as the code runs.
Yeah.
All right, just office hour.
All right, thank you so much, Shaman.
Yeah, thank you.
Yeah. Thank you.
Yeah. Thank you, Shaman.
Hope it helps.
It definitely did.
Thank you, Sharma.
No problem.